Okay. So hopefully somebody will check this for me on LinkedIn if you're there to see whether it is streaming live, because people are going to be able to chat with me there too. Okay. Okay. Oh God, it is waiting for broadcast. Okay, there's nothing I can do about it. Since you guys are here, I'm going to do this for you. We're going to get started. I'm just going to do one more thing to see whether I can do a stream to YouTube manually, because I have set it up to stream to 3 of the channels, guys. Okay, so I'm just going to go on. Are you done? Okay. So, hello everybody. Thank you for joining me. So today is the pre-class. So what we do is, I'm Sudha Jamthe. For those of you who are new here, I see a lot of new people. Okay, I see a lot of my students. Hello, hello, hello. Hello, John, Baptist. I'm glad you could come. Hi, Susanna, Suresh, I'm glad you're able to join. Please check the LinkedIn for me.
Yeah, hello.
Yes. Hi,
Yeah,
Baptist.
good, John. I got your email today. It was okay to join, so I'm happy.
Yes, thank you so much. And hi, Kari, hi, Cam, Dan, Adam, welcome. So those of you who are here on the Zoom with me, you get the privilege of being able to chat your questions and also speak up, right? So that's the advantage, and I don't have that open to everybody. But many of you who are watching the stream or come back, watch the recording, you should be able to still communicate in the chat wherever you are. I'll come back and respond. And of course, you can follow up with me later. Let me give that ahead of time. Sudha Jamthe at businessschoolofai.com, because I tend to forget giving my contact in the end usually. Okay. So what we are doing is, while classes is in session, we've had a bunch of sessions going on teaching AI, which is we were teaching machine learning, we were teaching natural language processing as live labs. And we have this inclusive AI ethics class going on with Susanna Raj currently. So those have been our current classes. So the next one coming up is my class called NoCode AI, Data Science for Business Users. And it comes with a dual option. You can just learn data science from me from tomorrow's class, and I'm going to tell you about it. Or we have a live lab, and I've separated it out for a reason. I'll tell you in a minute. And the live lab is something that I'm not opening up to everybody. I'm going to take only 10 people, or even I'm happy to take even less number of people, because the live lab is not just a lab you'll sit and learn from me, but we are going to work with the real business. And it's an autonomous vehicle delivery robot. I'm not going to give their name yet. And we're going to solve a real business problem for them. So my hope is you learn, a lot more people will come and learn data science from me tomorrow. Some of you are going to continue on and work with me and this company and go solve a real business problem using the real data. And so what I'm going to show you today is the pre-class for both of these together, which is NoCode AI, Data Science for Business Users. And what we do with the pre-class is it's an audit, so anybody can join in. So if you're seeing this and you want to invite your friends, feel free to invite them. And this will stay recorded so people can come and watch. So my hope is I'm not just going to give you a sales pitch for the upcoming class. I'm going to teach you something to give you a taste of what the class is going to be. So even if you don't attend my class, I hope that you'll get some value from that. So that's where I'm going with this. Okay, I'm going to switch back to my usual glasses. That was too big. Okay, so the no-code AI is a concept. And I've done a bunch of the sessions. So if you're new to this whole concept of no-code AI, I'm not going to spend too much time on it today, but we have recordings of previous sessions that we have done on that. But the general concept is no-code AI gives you a technology front end by which you don't need to actually know Python or any kind of coding. So one of the things we do with all our classes, when I said we have this class on AI ethics, we have this class on NLP or machine learning, we taught everything using no-code AI, which means you didn't have to know Python, you didn't have to look at, know programming, because the whole idea of AI is trained by data. And so if you're data savvy, that's more power to you. And that's where bulk of the time goes in building AI. But then there are models, statistical models, which is built using stats and math, but those models are available as from technology companies as APIs. So typically, if you're going to build AI, when they teach you how to, learn machine learning or deep learning or any form of AI, they will expect you to do some Python because you're going to call those algorithms and you're going to write some code. And so it's done by developers for developers so far in the past. But bulk of the customer data that trains AI is actually sitting with companies, and the business owners are product managers, business growth managers, various different titles of people responsible for operationalizing and growing and the business and managing customer relationships, marketing funnels, and the like. So those people don't need to learn coding. So there is a school of thought which I expects you to learn coding, and I belong in that class where I don't think you need to learn coding. Coding is for people who know good coding and they're good at their job. So you bring your business acumen. As a product manager, you're the CEO of the customer, and you need to bring that perspective. You could be a UX designer. Many of my students are UX designers, and then they move into AI. And so no-code AI is a bunch of platforms. So we use one called Akio. It is AKIO. It's double KIO. And another one called IBM Watson. Are the two that I will be showing in my class. And I have a recording of this done to show how to solve for customer churn using a data set. And the same data set I fed into Akio and to IBM Watson. So we will be using that no-code AI platform in this class as the last piece. Okay, so let me share my deck. I have a huge deck. What I'm going to do is I can't do justice to the whole thing. So what I'm going to do is I'm going to show you 4 pieces, at least 3 pieces in depth. So the last one is this no-code AI piece, and I'm going to give you a recording if that's of interest to you. So the way we will do this is the class has 2 sections. The first one is data science for business users, where you learn data science. So what I'm going to do today, as soon as I start sharing my deck, is first I'm going to show you what is data science. And within that, I'm going to show you 2 pieces. One is data science is about what powers the data, the models that powers the data. So you could be saying, hey, I want to learn AI and I want AI to solve this business problem for me. Say maybe we are, the self-driving car, my favorite topic, right? So the car watches the road, the data is all the videos and images that you get, and then you build computer vision models, and then you train the AI in the car to drive autonomously. That AI is called perception, right? That's how it sees the road. There's a lot more AI in the car, which is a different class that I teach. But all those could be voice in the car from an Alexa, or it could be watching your emotions, which is not ethically right, but they'd still do that, and interpreting your tone, or it just could be data and mileage from the car, or how well you're driving, when are you pressing on the brakes. This is a real thing because Tesla is now giving a full self-driving car feature, and it's an opt-in that people have to ask for. And to do that, they have to click a button and say, I want to do this. And then by clicking the button, they're giving permission to Tesla to watch the driving behavior. And it is actually going to say, when are they pressing on the brakes? Do they get too close to another car? All of that is being tracked in a transparent dashboard, and people are given rating about how well they drive. And then supposedly Tesla decides that based on whatever their internal cutoff is for good drivers, only to those people they're giving the self-driving car feature. So there's a huge line and a lot of people saying, this is my rating, this is what happened, and I think my rating went down because I got too close to another car, whatnot. But the idea is people are sharing their own driving behavior from inside the car. So all the sensors in the car is connected, and that is being shared. So that becomes regular data stream from sensors, and that is machine learning, right? So the data could be any kind of data that is going to power the artificial intelligence, which is doing something intelligent with the machine. So, and a fundamental meaning of artificial intelligence is getting the machine to be intelligent, to do some automation, do some prediction, to do some things that's not dangerous for us or mundane for us or monotonous for us or just huge volume involving a lot of computation. So that's AI. And within AI, there is what I've been saying, right? Machine learning, computer vision, or natural language processing are the three areas that is prevalent out there today. So you could go learn that. Again, you could learn that using NoCode AI, or you can think about, okay, I want to solve a business problem using this AI. Now, how do I go about it? So the data science is the data behind it, not just the data, the modeling of the data, making sense of the data that the statisticians do. And they create a lot of different algorithms. That is the bucket called data science. Professor Andrew Ng actually shares my philosophy, and he's a genius in this space. And he talks about how data science is about managing the data all the way through to get the data right to make the model work. So there's one school of thought which just thinks data science is machine learning, deep learning, all the different algorithms. And the other school is it's bigger than that, how you get the data to iterate to make the model work. So I belong in that camp, but I'm going to teach you only the model piece today. So coming back, let me share my deck. What I'm going to do is, for data science, I'm going to give you a sneak peek, and I'm going to show you models. What are the basic models? What will we be covering in the class? I'm going to give you a sneak peek of that. And then one super exciting topic in the world of models is called fundamental models. And I'll tell you what they are. I'm going to show you some live demos. I like to not just give you theoretical stuff, but give you something more hands-on or tools so that you can go build something with it. So I'm going to show you that. That's the most exciting part of this session. If you're coming here for the pre-session just to see what am I going to teach, this is what it is. Okay. If you're interested, obviously you can sign up for class tomorrow, and that's a 2-hour class, and you can learn the data science piece, foundation, right? Then the next part is the LiveLab that we're going to use with this autonomous vehicle company. And that piece, I'm going to show you what I will teach and how we'll go about it. I'm not going to give you the exact business problem or the data. I'm not allowed to share the data in public, but I'll tell you what that looks like, or what is the process and the experience students will go through. All put together, we are shooting for 6 live hours of class. So 2 hours will be the data science tomorrow, and then the 4 hours will be the solving the business problem, which will be spread out over 4 weeks. That's my plan. Okay. Any questions, comments? Do you have any burning question that you want answered? Hi, Ananya. Good to see you. Hi, Arnan. So is there anything that you want answered? So I'm going to show you the data science, which is the basic models and fundamental models. I'm going to spend a lot of time on fundamental models because it's a cool topic. Then I'm going to show you what the live lab is, what is the process we will follow, or what am I really teaching in how you're going to take a business problem to solve and build for a AI for an autonomous vehicle delivery bot. So that's my plan. And we have 45 minutes. I would like to keep it interactive. If you have questions for me, I would love it. So can you please talk to me and tell me, what do you want to do with this? Like, is there any burning question in data science or like this fundamental problem? In fact, the whole beauty of the world of AI is it's so full of controversies. And so you would hear people, I even hear from people saying, the definition of AI versus data science is not agreed upon. So that's what I was asking, whether you have any burning questions, then maybe I could help you with that. Yeah? No? Okay. Can I go share my deck? And you can chat your questions, comments, if you want. And I will answer your questions and let you speak up if that makes sense with my flow. Otherwise, I will still come and answer your questions. Yeah, that's fine. At least for the people here on the Zoom. Okay, so I'm going to share my deck. So here we are, data science for business users. It should be users and LiveLab pre-class. So I'm Sudha Jamthe. I teach at Stanford at continuing studies. I teach AI for product and business managers. I'm a technology futurist. I teach in a couple other places, but that's for another day. So I already told you what this course is about. The one interesting thing that I would say is you're going to get guidance from me. That's what we do with all my instructors at Business School of AI. You will get office hours, one-on-one time, so that you can learn at your own pace and finish what you set out to do. But in this one, the data science class, you would come and learn together as a individual or with more people. But as soon as we switch to the mini lab, the live lab portion, it is not going to be individual. You're going to work in multidisciplinary teams. So this is something that we had experimented, perfected. Supposedly, I think we made it better. And we did that successfully last time. And so it has worked for us. So we tried to simulate close to a real world team setting. So in a real world setting, when you try to build AI is not built just by the data scientist. So there's the data scientist who will build the models. Then there is the machine learning engineer who will work with the data scientist to go code the AI to give it a UI. And there will be the product manager who will guide that experience. There will be designers. And there will be so many other business roles who have a vested interest, who will define what the metrics should be. So when I asked a data scientist, I have it here. When I asked a data scientist, what is the process of building an AI? So there's a difference in how the data scientist looks at it and how the business user looks at it. So I spoke to one data scientist and she said, oh, we start with use case identification that is done by the business user. And then this is the rest of the stuff that she goes off in designing the conversation, analyzing it, training the bot, deployment, integration into the backend. So that is one piece. Then I spoke to somebody else. This is Namit Naisurana, who's one of my students. And he actually came and went into great detail about the actual data. How do you ingest the data and the various data teams, what do they do? And the various ML teams, what they do. And then it goes to the same, this ML team process evaluation and iteration and integration and all that stuff goes into production scale of AI that he was talking about. But what the data science team is doing, the data teams are doing is still not data science, right? That is still cleaning up the data and stuff. So sorry if this sounds confusing. It is confusing because different teams say different things in companies, right? That's the point I want to make. Then I spoke to a data scientist who basically went into a different dimension of it and says, we write Python code, we do the front-end configuration, we push it to GitHub, we give access to users, and we do this thing, right? So this is a data scientist, Maria Henningsens from IKEA. And so if you see, it looks confusing as if there are different things. But if I go back here, this is the cleanest one I can show you. The data scientist is doing something which is behind the hood, and the business user is giving the use case identification. So even if you just get that piece, that is good enough for us to get started. Okay. So what I'm going to do is, so when I say AI, we are talking about variety of different AI. Most of it is machine learning. Okay. And I'm going to show you at a fundamental level, all AI is taking the data, looking for some patterns, and it is making a prediction. But in making that happen, there are data scientists who are taking the data, who are building the stats model, which will create this in the brains of the computer. That is data science. That is what I'm going to teach you without such scary images. Yeah. And then when the model is ready, it's like a piece of software. It's like a piece of software sitting in the autonomous vehicle, and I go and it starts driving. Or it's that chatbot which is coming and chatting with me, like the one that was chatting with me for customer support today before I came here. Or the autocorrect that is on your phone, the spam detection that's in your email, all of them are the same thing. So this is very, very, very critical for us to understand before we proceed, because what we are doing is everybody talks about AI as this one big blob, and then they throw a lot of jargons at us. And so if you want to get one thing out of this class or working with me, even in any of my free classes, is jargon is a jargon. We need to demystify it, and people should be able to explain what it is. If you cannot explain it in simple English, I don't think it's worth it for us to learn it. Or that person is not able to explain it properly. So all AI is going to be, this is the foundation of all AI, not just machine learning, but all AI is being trained by data. And the data scientist uses math and stats to create some kind of pattern, which is all hidden and not transparent in the brain of the algorithm. And they spit out an AI model. And they say, okay, the AI is ready, and say it's supposed to recognize my face. So they give a lot of pictures of faces, and it forms some pattern and says, I think I can recognize this face. And then they have to test it out. When they test it out, it doesn't recognize my face. Maybe it was not trained. If I wear my pretty glasses, it might recognize me better. So you need better images. So they go back into this iteration. So the frustrating part of making AI work is this endless iteration till you get to a place where it is predicting right. That is why autonomous vehicles have been driving around in pilot mode for 10 years, and they're not ready yet to just drive amongst us and with 100% guarantee that it will recognize a duck, or if a cyclist walks around and wobbles drunk. I don't know if that's not in the training data. It might get confused and say, no, cyclists are supposed, this is the shape of the cyclist, this is the shape of the human, this is how they're supposed to go. So that's what happened with the Uber car, and it hit a pedestrian or a bicyclist who was crossing the road, but had a big bag on their bicycle, and it kind of messed up the shape of what it expected as the bike, and it kind of threw it off. So coming back, that's what we are going to do today. When we are talking about data science, somehow we are going to not see the inside of this, but we are just going to see how the training happens. Yeah. Okay. So if you want to understand what the data science algorithms do in simple English, whatever their names, whatever they're called, it doesn't matter. They do 4 things. Every possible algorithm in the AI world does one of these 4 things. It looks at data, and it classifies and organizes and looks for pattern. And it says, oh, this so looks like one group of voice. And next time when you bring the similar voice, it says, I can recognize that as Sudha's voice. It could be for faces. It could be for spam. It could be for anything. It recognizes patterns. So that's one thing it does. The second thing is it organizes it for patterns. The second thing is it recognizes it and says, oh, identify this person. I recognize this person. The third thing, it says, okay, now let me make a prediction. Let me make a recommendation. And based on your movie watching pattern, I would recommend this next movie for you, or I would recommend you buy this cereal because you seem to be buying milk that goes with it. So that's the recommendation, is the third piece. Anomaly detection is finding the odd man out. So the most common example of anomaly detection is spam. So you get a mail from certain set of people, and it has certain patterns, and this looks like it is, it has a huge attachment or some kind of spammy link. Or it could be just, I'm used to buying from a credit card at a certain denomination, and suddenly I'm making a charge for $1,000. Or I'm used to shopping from here, and suddenly, I'm showing up at Timbuktu, and so it looks like an odd behavior. So that is anomaly detection. So these are the 4 things that every possible AI is doing. So how do they actually manage to do that? Let me go to the algorithms piece. Bear with me. Okay. So we spoke briefly about AI versus algorithms so far. AI is the promise, the intelligence of making machines intelligent. Data science is taking the data piece, building models, making sense of it, so that the AI can make the decisions or predictions or recommendations or find the anomaly. So the 4 things for the AI. That's what the AI does. AI does one of those 4 things. Data science takes data and does some magic internally with math and creates models that the AI can use to build applications that we want to build. So that's the difference between AI and data science. I have to put it here because every time I talk to somebody and talk about this AI, what is AI, what is the scope of AI, there is a lot of disconnect or conflict in the AI world about, hey, that is not AI, that is not really machine intelligence and things like that. So there's a term for it called AI effect, the AI effect, and if you look for it in Wikipedia, you can see research and behind that it's called AI effect, where the AI specialists do not disagree on what is AI, and they basically keep changing AI to that's been done, that's normal stuff, that's not AI. So AI is essentially anything that's not been done before has become the new definition of AI. I don't subscribe to that. I just want to let you know, if you go about saying, hey, I took an AI class and I can do this, that with AI, there'll be somebody saying that should not be called AI, this should be called AI, or even the definition between data science and AI could be a fine line. Okay, so now when we come to understand algorithms, so what I promised you is in the data science class, we are going to learn models, algorithms, demystify them in English. And the advanced version of this is fundamental models. Those two things I'm going to give you a sneak peek today. Yeah. And then all that long story I told you about how the AI process works and how it is done, all that is to lead you to how we will do the lab part, because we are not going to take 3 different versions and confusing thing. I have a very simple way. That's why I'm promising in 4 more weeks of 1 hour each, working with a business partner for a real company, we're going to build an AI model to solve a real business problem for an autonomous vehicle delivery company, right? So that's why I was giving you that detail. So what we have done so far is, this looks like a long process and people don't have agreement on the steps of how to build AI, but there is something called AI, which is basically taking models, algorithms, and solving business problem. And it does 4 things. And data science is how you build that model and algorithm using data. So far, so good. I want to see whether anybody has any questions, because this is the confusing part and I've been talking for a long time. So I want to pause and see whether you have any questions, and then we can proceed. And now I'm just going to show you the different models and the fundamental models for the next 10 minutes. No? Yes? Okay. Okay. So when the data scientist builds an algorithm, when they do data science, what they're doing is they're taking data and they're doing some math and they're creating models or algorithms, right? So the number one question that we need to know if we are involved in any form of AI data science is your data structured or unstructured? What does that mean? Unstructured, so it leads to 2 different kind of learning. So if it is unstructured, the kind of algorithm they build is called unsupervised learning or deep learning. And if it is structured, they build what is called as machine learning. So in most places, when they say, hey, AI does this, AI does that, they're talking about machine learning. And so in the simplest form, a structured data is any data that has rows and columns, and you can actually see and understand what it is. So if you're looking at customers coming in and this is their behavior, this one, I think I have the churn data that I was using. So this says, this is the customer ID, this is the gender, these are the different factors. Factors is the word they use to show different columns that describes the data. So this customer has dependents, this customer is a senior citizen, and then there will be one column which says this is the customer churn, yes or no. So that is structured data. And so when any data is fed to an AI, if it can be structured and broken down into rows and columns, then it's structured data and it does supervised learning. The trick with supervised learning is, if you give me a spreadsheet and give me this information, maybe I am not going to be able to sift through millions of data like an AI would do, but I can look at this and say, this customer is male and they are not senior citizen, and looks like this is what they did in terms of churn. I can look at the answer of what it should be. So if you show me spam and not spam as structured data and say, spam is, email that comes from a known friend, does not have attachment, there could be different things. We could define what the columns are. And then the not spam. So the not spam one is the one from the friend, I'm sorry. And spam has some kind of link, phishing link, this, that, right? So if you have something structured like that, I can look at it and say, oh, I know what the answer should be. That when you show me something, I can tell you whether something's a spam or not. That is structured data. Structured data, supervised learning means the data is in a spreadsheet or in a form that we can see columns and factors, and we can find the answer manually. I know what is the right answer. I just want the computer to find the spam for me because it's a lot of emails sorting. That's the supervised learning. The unsupervised learning is unstructured data. When you look at this data, it's a picture. What is in this data? This lot of pixels of colors. As a human, I know this is a car and this is a bike with a person. This is the road. There are some trees here, but the AI or the computer or the machine doesn't know that. It just knows this as a lot of different colors. We can say, hey, this green color here is a bus. But if we don't label this and put boxes around it and train it to understand a car is a car, this is what a car looks like, it cannot do it. And so what the unstructured data, the unsupervised learning is when you do facial recognition, when you look at faces, images, when you look at videos, what the self-driving car is doing in terms of videos, that is also unstructured and unsupervised learning. If you get a stream of voice, like I keep talking and it has to recognize my voice compared to my dog's voice. And actually there are, my device at home can do that. You can say it hears the dog's voice. I don't know if it can recognize my dog's voice specifically, but it recognizes the dog. It says dog barked. And so that is unstructured. And so it's a stream of data. And in this case, it is actually a bunch of pixels of various colors. So that is unstructured data. So why am I saying that? When you get started to understand data science, whether you're a data scientist or you're a person in any of the business role, product manager or business person, working with them to understand data science, you just need to know what's the starting point. Is it being trained as structured or unstructured? Based on that, they're going to use different algorithms. So now I'm going to give you a quick version of this. So don't feel alarmed. I just want you to get a grasp of what is possible under this realm of data science and algorithms. In the class tomorrow, I will spend 2 hours, the data science for business users class. I will spend 2 hours teaching you a bunch of algorithms, which are more famous known algorithms in English. And I will tell you how it is done under the hood. So when you take structured data, the machine learning models, I'm going to show this with the NoCode AI platform when I do this in class. And it will say, yes, voila, here is the model. Under the hood, remember we said, what are the 4 things the AI is doing? Looking for patterns, looking for anomalies. It is recognizing objects, and it is making predictions or recommendations. That's the English version of what any AI is doing. What the data scientists, when they go to build inside, they're building models, they're going to say, am I going to do a classification or regression or clustering? These are the 3 kind of models that they will build. And so classification is, remember we said supervised or unsupervised for structured or unstructured data. So classification and regression are supervised learning, and clustering is unsupervised learning. So I'll give you the harder one, which is the unsupervised learning. So if I feed an image of my face and train an algorithm to recognize images, or like the picture I showed to recognize cars, what it is doing is it is saying, oh, this set of images together, where is that unstructured image? Oh, this cluster of pixels together defines a car. This cluster of pixels defines the bus. This cluster of pixels, this group of dots on the screen defines a person with a bike. Or this patch here can be defined as the pavement. So that is what it is learning in its brain. As unsupervised learning is assigning data to a cluster. And it just looks for similar items and it just forms putting them together. So when you feed a face, it will say, oh, this is the eyes, this is the nose, this is the cheekbones. That's what it will try to understand. And once it's grouped it and said, okay, now I can actually tell you one face versus another, because I'll compare eyes to eyes, I'll compare nose to nose, and things like that. So that's what it is doing in its brain at a fundamental level. So coming to supervised learning, remember supervised learning was structured data. We knew what the answer was going to be, and I kept giving the spam classification as the example. In this case, the classification is, hey, is this a dog or this is a cat? Is this spam? Is this not spam? It's classification. It's called binary classification, which means you take the structured data and it just groups it into two groups and says it falls in this category or this category. So that output is called categorical output, means it has a single number, yes or no, 1 or 0, dog or cat. So, and that algorithm, the way it does it is called logistic regression. And I'm going to show you visually how does it do in the brains of it tomorrow, just for curiosity's sake. We absolutely don't need to know that. We just need to know when you get to work with people and your product manager or your AI ethicist, and you're saying, hey, your data is biased and it's not doing the right thing. So you need to understand whether it is dealing with structured data, unstructured data. Structured means it's doing supervised learning. Otherwise, it's doing unsupervised learning, which means they have no control. When the self-driving car is going and hurting people or hitting somebody and it is, runs into an accident, there is absolutely no control in the hands of the data scientist who trained it, because they just fed images and it formed these clusters. And so their best case of what they can do is they can train more and more data with more and more of these clusters. So if it does not recognize the human with the long hair, then you need to give the human with the long hair as training data. That's the only thing. They cannot do anything else if they're doing unsupervised learning. If they're doing the same thing with classification or regression, if they're doing structured data, again, they have to give more data, but at least you can see on the inside of it, it doesn't recognize spam if it comes from a friend who already emailed me, but now the friend is spamming me now. And so I need to add another data which shows a known person, but define what is a spam through some other columns. And so this is where your business acumen comes in understanding the data. That is why understanding how the insides of the brains of the algorithm, which is data science, helps you, because now you can actually know to break it and show when it is buggy or it is not solving a customer problem or get better data. So that is the classification is just Boolean, right? Binary, yes or no, spam, no spam, and organizing the data into two buckets. Regression it's exactly the same thing, but it is not just one versus the other. It's a continuous stream. So if you're trying to make a prediction or a forecast of temperature or weather, it might not be, yes, it's going to be 90 degrees or 97 degrees. It could be along the spectrum, which is a continuous curve. So in the brains of the algorithm, it's creating math. In classification, it's creating a straight line. In regression, it is creating a curve. And it's called sigmoid. It's like a S curve called sigmoid. That's what it is doing in the brains of it. So that's so much for these three. So most of the problems that you're trying to solve in data science will be solved between these. And this algorithm is logistic regression algorithm, and this algorithm is linear regression algorithm. And unfortunately, it's confusing. I felt that in the beginning because it's classification, and this also is called logistic regression. This is called linear regression. So why is this algorithm called regression when it is but that's what it is. So that's the crux of what this is. And there are many, many sources which will tell you when you will do this. And now I want to do a little exercise for the class saying, is this machine learning? Or basically, I want you to tell me, is this structured and supervised learning, right? That it's structured, we know the answer, that's machine learning. So you're going to tell me, is this machine learning, yes or no? Can you chat your answers? I just want to hear a yes or no. So here we are looking at I want to increase customer revenue and marketing, and I have three segment of customers. So I've grouped the customers into three segments. Is this machine learning, yes or no? Let's see, I'm seeing an answer. Oh, 3 messages. It is structured. Yes, thank you. Yes, yes, guys, thank you. Next best click is a very common one. Now the customer, we gave them this, we send them, emails, we send them coupons by, maybe we call them on phone, maybe we, met them at events, we say, give them flyers. So this is what the customer responded to. What is the probability of the next channel that the customer is going to respond to? So this is a very common kind of algorithm where, again, you have different rows and columns of the customer responded to email, the customer opened the email, the customer looked at this content, the customer showed up at this conference. No, the customer did not respond to the phone call. And now you want to see what is the probability of the sale on, if you were to call them or email them, if you want to send them a discount, which channel is best to send it. And this is called propensity model. Now you can find out what is the propensity of closing a sale on which of these channels. So that's a common one. Is it structured, unstructured? Yes or no? Is this a yes for the newest one? Regression ML. Oh, Sanyukta is ahead of the curve. Yes. So you're essentially doing regression. Remember we said, oh, you're just going to take groups like that, right? And I showed you the 3 options. Yes. So what about the voice assistant? I'm talking to Alexa. Alexa loves me. Keeps telling me jokes. What's the data? It is unstructured. Yes, it is unstructured. So it will have to be some form of unsupervised learning. If she wants to understand my voice and knows whether it's my voice or the dog's voice, it has to be unstructured deep learning and unsupervised learning. Okay, what about this? This is done in computer vision to identify fruits. Drones fly around and identify whether a fruit is ready, ripe enough to pick or not. That is being done in agriculture. All they do is they have cameras, they're looking at that. The image that they see from the camera is the data they're using to train. Now, is that structured, unstructured? Structured means if they're going to do machine learning or they're going to do supervised, unsupervised. Yes, no, it's unstructured. So they're going to do deep learning, unstructured. Okay, I already gave this example. Maybe I should skip this. So fraud detection, right? So it says that's an outlier. This is the normal amount that you buy from. Now it's different, right? So that is anomaly. So I'm going to skip that because you already know that it is structured because it's just spreadsheets. Okay, so in the data science sprint, that's what they're doing. Okay, so I've been through that example. I do this in class, and some of you might have seen this. We use this NoCode AI platform called Teachable Machine. So if you're interested in looking at that, take this URL. It's called teachablemachine.withgoogle.com. And then I will just enter, upload literally a bunch of images to show apples versus oranges. We'll train the model live, and then we will test it to see if it recognizes it. So this is one of those computer vision models that we will do in class. So coming back to the models, one of the things I'm going to go deeper. So what I showed you is the high level stuff of what you will, the structured, unstructured, classification, regression, clustering, right? That's the table stakes. Beyond that, there are 5 different kind of classification algorithms. Even if you use a NoCode AI, thank you guys. Even if you use NoCode AI, it will be using one of 5 algorithms. So Suresh or Ananya, who just finished up with the machine learning class, you did a regression model, right? If you, there could be 5 different kind of backend in the brains, there could be 5 different kind of ways classification can be done, 5 different ways regression can be done. So there are names for these. So the data scientist will actually try to refine the model to pick one or the other model. So the more common models are these: logistic regression. You saw that in my list. There is one called naive Bayes, k-nearest, decision tree support. It's called SVM, support vector machines. So one of the things I'll do tomorrow is go into this. So one myth that everybody has is the business person typically says, what is the best algorithm to use with my data? Or what is the best algorithm to use for this business problem. And there is an attempt to go make that happen, saying, oh, no, maybe they're using logistic regression. That's why it's not getting the performance. It's not predicting accurately. Maybe they should be using k-nearest. So by experience, data scientists have found that certain algorithms are good when you have large volume of data. Certain algorithms are good when you have less volume of data, or when you have gaps in your factors. You have data, structured data, but you don't have enough factors. So there are reasons when you will go with one versus another, but there is no exact science of this is the way that this is one algorithm is better than the other. So one of the exercises I have done is I've gone out to industry, talked to people, try to see what is the business model, what is the business problem they have that we can solve with an AI. And they're all stuck in one place where they say, we have an algorithm, but it's not performing well. My data scientist is trying to pour more data into it, or we are trying to refine to switch to a better algorithm. So I want to pause here. Even if you got nothing out of this, because it looks like a lot of new terms, I'll give you the recording of this, so don't worry about that. But one thing is, there are various models that creates the brains of the data science algorithms, right? And when you solve an AI is built by feeding in training data, and the models are built. So now when the model is not performing, the self-driving car is not ready for mainstream, and we want to run robots, or we want to do a delivery bot and we want it to go deliver food. Can we trust it? Now it is showing only 70% algorithm efficiency. Maybe we want 90% efficiency, so we can confidently send it out in the road. So the two way this can be solved is you can give it more and more training data and say that training data quality was not good. It did not have all the different conditions it should have. So give it better training data. The data scientist would say, I use this one algorithm. Maybe I can fine tune the model to use a different algorithm. So it's called hyperparameter tuning is what another way of doing. So one is you solve by improving the algorithm, or you solve by giving better data and iterate the model. So when I use a NoCode AI platform, it actually will do all this in the brains of it. It will take the data, it will fit against 5 different algorithms. It will try to hyperparameter tune all the different algorithms, and then we'll say, hey, here's the answer. This is the model I have used, and go ahead, start using this AI algorithm. And I can tell you, I can give you 70% confidence or 90% confidence. It will tell you the output of what the confidence level is. And then you can decide, I'm not ready. I will put more data into it and improve it. So internally in companies, you will find the data scientists saying, I cannot do more. I've done all the tuning of the algorithms, and you need to get me more data. Or the business person might say, hey, are you using the right algorithm? But if you're the business person and you don't know, all this looks like gibberish language and says decision tree versus naive Bayes, then you cannot have the confidence to say, maybe you need to do this differently and have a conversation of equals. And so my hope is you will understand tomorrow, at the end of tomorrow's 2 hours class, what is the English version of what's done in the brains of these algorithms? Is it even useful to even ask them to switch algorithms to try anything else? Maybe you start off a whole new business, you don't have customers, you're just using some data from the internet to start making recommendations. And then you're going to improve once your customer interacts with your data. What model should you be using? And you don't know, and you don't want to be so ignorant in asking your data scientist. So I'm hoping that you will get the English version of that. So the coolest thing I'm going to is the final version of where the reality of data science today is. It's called fundamental models. And the funny thing is, nobody disagrees about this. There are people who are saying this is good, this is bad, this is not quite ready of the fundamental models. But the real conflict in the data science world is, should we call these fundamental models or not? And there was this whole discussion and argument. I'm not taking any sides. I'm here to demystify this for you. So the concept of, what I showed you is there are various different models, various different ways of fitting that stats line into a straight line, or that sigmoid S curve that I told you about. So we can't keep on training every AI to do the same thing again and again. And you have to build models for voice, we have to build model for data. We have to build models for image, right? To understand text. So the three different areas is machine learning is everything, like general data, structured data, right? The computer vision is looking at images or videos. And natural language processing is taking documents, voice, anything, but trying to break it into English or any language construct. So understanding language is natural language processing, understanding images is computer vision, understanding any kind of data. Sometimes it could even be unstructured because it's huge volume of random data, which we don't even know the patterns of, but that is machine learning, right? So there are three different areas where algorithms researchers, data scientists are improving and creating more and more model. It's an endless game because they have to go in three different paths and keep innovating. So the fundamentals models is a concept where they said, hey, why don't we create some model that would make us iterate and innovate faster instead of just creating unique models one at a time for each of this. So the first thing that came is called GAN, or Generative Adversarial Network. What they did is they said, hey, we have only so much data, and with the data, we can train only so much. So we are stuck where we don't have much data. So this whole fundamental models is based on the concept that instead of humans creating more and more and more models, the idea is, what if the AI can create the model? The AI can be smart to train another AI. It goes into a dangerous realm. So you would have all these discussions of AI is going to be the master of everything in the end. I'm not going there. It's nowhere near there. AI has no intelligence today. The AI in the AI is just a joke. But we have the promise of where it could go, right? So what they did with GAN is somebody said, what if I can make the AI generate my training data for me? So they started with images. So what they did is, what is an image? Like, remember the picture of the car and the road we saw? It's just a pic. It's like a table of dots with multiple colors. That's how the computer understands. It's a matrix of colors of pixels. That's what an image is. So they said, what if I can make the computer generate an image for me? I can make the AI see whether that image is a face. So that is how GAN was created. And that is the foundation of synthetic data that we have today. So a lot of images are fake images, and the whole fake news rides on that, unfortunately. But it was done with a good intention to create images, make the AI create images. So they had something called a generator, where it will generate images. And there's that's one AI. And there's one called discriminator, which is another AI, which will actually say, hey, you gave me this image. It doesn't look like a face. It doesn't look like anything. It's just skewed. Dump it. Now give me another image. So what they will do is they will retrain it in a cycle. So the generator will generate an image, feed to the discriminator. It says, I don't recognize a face. Do better. And sends it back. It'll improve it. And they kept on iterating till it says, aha, I see a woman with glasses. Right? So it basically, they trained it with man with glass, a man without glass, and then a woman without glass, and then it gave a woman with glass. So it learned and put this together, and then it created it. So that is an example where you could create data from nothing. So that is one of the advanced models. So then there is a broader category called transformer. And this came from Google, I believe, called BERT. This was a big breakthrough. What they did is they took language modeling, and they did next sentence prediction, and they built this model called BERT. And that was a huge breakthrough in the natural language processing world, where instead of it being supervised learning, which means you take language sentence and you break it and you recognize the different factors and you train the algorithm. So when Sam Wigglesworth is teaching us how to build a virtual assistant, how to build a chatbot, we are basically doing supervised learning. We know the answer. We know the structure of the sentence. We break it into words. and then we train the model, is what that is done in the brains of what we are using today, right? That model, I'm just talking about what's the inside of the model. And what Google said is, what if I can take the entire Wikipedia and treat it as unstructured, and I don't know the answer of how to interpret language, I will just make AI create a model that can do modeling and understand language, and it can do next sentence prediction. And so that was a big breakthrough. That is BERT. And this is all comes under a category called transformer. Transformer is the name of the technology behind these models. So the newest one with it is called GPT-3, which is supposedly, it's just by OpenAI, which is now bought by Microsoft. And OpenAI is a foundation funded by Elon Musk and a few others. And they have created GPT-3, which is supposed to understand language very well. So that is one model. And the latest, greatest one in there is called DALL-E. It is Wall-E, is the E where it is coming from. So you can actually not just do language, right? So some of the models were doing language like BERT. Some of them were doing images and creating images, right? And GPT-3 was a better version where it can do language better. The DALL-E is the latest, greatest in fundamental foundational models, where you can actually give a text like you will do in natural language processing, and it will create an image. So I'm going to show you a demo of this because I've been explaining all these models in so much excruciating detail in just words. And so you must be like, okay, it's too much. Why do I need these models, right? So what I'm going to do is I'm just going to show you a quick demo. I'm going to stop that. So I want to pause. I'm at the end of the hour. I promised to show this. I've just given you theory of what is structured, unstructured machine learning models, 5 machine learning models, and foundation models, right? I'm going to show you a demo of the foundation model. So if you have a little bit time, I can continue and just show you a demo of the foundation model. And then I'm going to close out and show you my secret sauce of how we will do the live lab for the building the algorithm. So I need at least 15 minutes. So if you want to drop off, you can come watch the recording. Otherwise, I'm going to continue on. And if you have any questions, please ask now. Yeah. Okay. And I'm trying to give you a quick version of this. So in tomorrow's class, I will go through each one of them and we'll do something live. Each one of them. And I want you to understand the English version behind it. So don't worry about it. Okay. But for anybody who's not going to come back tomorrow, I want you to have enough of a foundation. So you know that there's an English version of how things work in the brain, and you don't need to be the one building it because that's not your job. Whoever is building it, even if they understand the details of it, can go build on it to the next level. Okay? That's how I'm thinking about it. Okay, so let me find my window so I can show you the demo. So what do you want to see the DALL-E one of how it is doing it? Let me see this. Hold on. Okay, can we do this write with transformer? So it is just going to write. And remember, it can do the next sentence prediction. So that's the easiest one. So the most common famous transformer is called Hugging Face. So it's transformer.huggingface.co. For those of you who want to go home and try this on your own. So it's basically a modern neural network. Neural network is a kind of algorithm which has many, many layers. It tries to simulate the brain. It's unstructured, unsupervised learning in its brain, right? So what we are going to do is it's going to write, it will auto-complete your thoughts. How dangerous does that sentence look? It will auto-complete my thoughts, and I'm going to put it to the test. So I'm going to start writing. So this is built by Hugging Face. Lets you write a whole document from your browser and try one of these examples. Okay, today scientists confirm the worst possible outcome: the massive asteroid will collide with Earth. Okay, and impact the Earth is one option. Okay, now, oh my God. It's supposed to give me the next sentence, guys. can we do? Okay. Last night I tested it out. It kept coming back and chatting with me and giving me more.
Sudha, do you have to click that trigger autocomplete on the top over there? Or?
Ah, okay. Thank you. No, this is, oh, it's continuing here. Oh, it's bad design. Okay, bad UI. So thank you. I saw one yesterday which had like a chat, right? I would say Steve would reply. I would say Steve would reply. So this is a different version. It's just a different UI, but thank you for that. So it continues on and says, today scientists confirmed the massive satellite collide impact this, that, the Earth, impact the Earth. And then it starts saying the Earth is spinning. We'll never know. Earth is our planet, or it was so massive, Earth would explore, and we didn't, and then it can continue on. So it didn't know, did not think, so it corrected that back. It would happen at all. And so you can continue on, and it should not be, and it's telling a whole story. So that's the idea. There's a bunch of startups which are taking this and saying, oh, we don't need humans to do copy editing anymore. We can do the AI do that. And there's 300 startups that I know who are trying to do copy editing with this space. There's things like that. Okay. Thank you for that, Samyukta. I would have like waited indefinitely, waiting for my smart AI to do something. Okay. So the other example I wanted to show you, I wanted to see whether I can show you the DALL-E one. The GPT-3 is also a good one. Let me see whether I have that. So this was premiered, this GPT-3 of supposedly this, like we saw with the text, it wrote a whole movie. And so that was premiered at Sundance. And this is Lucy.
Oh, wait, I'm even more nervous. I'm a bit tired. I didn't know post-production was so much work. We finished the movie
That's the
late
AI
last
talking
night.
to you, GPT-3.
Oh, wow. Wow. Great. Yeah. Post-production is always challenging. Hey, Lucy, I can finally see you. Awesomeness. So it looks like you're all set and ready to go. So I'm going to pass it on to you. The floor is yours.
This is the demo from Sundance.
Hello, Sundance. My name is Lucy, and I want to show you my new movie today. A friend of mine said that you aren't supposed to tell everyone about all the things that should be better or are wrong. You should just hit play. So that's what I'll do. Here we go. Oh, wait, maybe one thing. Pig Puppet, the star of the movie, is with us today. Maybe he can answer some questions later. Oh, and one more thing. This might be too scary for little kids. It has a lot of blood in it. So it's not for little kids or little pigs. So if you're a little kid, close your eyes now and your ears. Music can be scary too. Let me know if I need to turn up the volume. All right. Oh my gosh, I hope you like it.
So much emotion. This movie was completely done by GPT-3, created by GPT-3.
Where does it get the images from?
That's Lucy. Okay, so I'm going to stop here. So you can see the same pattern like we were doing with the NLP, the chat that I was showing, where the transformer was doing the writing for us. You can see it's kind of doing the asking a question, the other responding back and forth. It's a conversation. So it was, the images was also part of the movie production that they did. But the actual questions it asks is the real thing that came from GPT-3. Okay, good question. So I've showed you the brains of the data science, at least what the basic algorithms are, and we went straight to fundamental algorithms. So you can leave this class and say, I know what are fundamental algorithms. At least we covered 3 of them, right? We said what is GAN, BERT, and we did the transformer to write, and then GPT-3, that's, the latest, greatest in language. And then DALL-E, I'm not sure whether I'll be able to show you a demo of DALL-E. I'll be showing that in class tomorrow. We'll do a demo because I have a question for the class. So GPT-3 is chatting. Why are these called fundamental algorithms? That's the thing. So I think the Stanford team, Dr. Fifi Lee is like a pioneer in this whole image space and computer vision. From, created the first ImageNet data set that we use for computer vision training. They came up with this thing called foundational algorithms, and people are like, why do we have to call them? It seems to imply that it's more intelligent and more generalized AI and not a narrow AI. So that's kind of a argument discussion that's going on. It's in my perspective that an AI can generate other images, created the whole world of synthetic data. And it helps you train models where you don't have enough data on the good side, right? That an AI can actually do unsupervised learning for conversations, led to the chat, writing stories, copy editing, or the idea with GPT-3 that yes, you can do so much more. So we had Christine Kalnina as our speaker at Weekly Wednesday, and she has learned NoCode AI, and then she's now learned GPT-3 and built a model with GPT-3, and she's a UX designer who took a class with me. And so you should watch that video if you want, because she talks about how she went through the productizing exercise with GPT-3. And for all purposes, think of these models as a black box, and it's going to spit out an answer, but you have to give it a data to train it. So GPT-3 has been trained supposedly with the whole Wikipedia and improvised even beyond that. So it is capable of having a conversation, holding a conversation, and generating content. So you could have built chatbots. Sanyukta, you're thinking of I remember having a conversation with you about NLP versus GPT-3. NLP is supervised learning, where you're looking intent by intent by intent and improving the model, right? And like you were doing in Sam's class, with GPT-3, supposedly it knows everything. But then it has its limitations. So there's a lot of articles you'll see on how much it is, because no AI is 100% certain. So that's the NLP world. So the NLP world has been running along. The image world has been running along and doing better and better prediction. So now the foundation models are putting them together, and they're saying, okay, we don't need to be training only images, only NLP separately. Let's start getting to improve the models together. And so DALL-E is the latest, greatest, and you have to get waitlisted and then get access for it. I have not got access for it. GPT-3, some of my students have been able to get access. So that's what it is. So with that, with DALL-E, what you can do, I have a question for you, and then I'm going to tell you how we will solve the problem in one slide, right? With what is our approach to do the training data and get the business model for the autonomous vehicle business. Okay. And if you want to drop off, we can, I'm going to wrap up in a couple of minutes. So before that, I have a question for you. And if you're dropping off, I would still like you to reply back and answer me. So DALL-E is actually taking text, so you can talk to it, and it'll create an image. So we showed GAN how it can create images. You can take text and understand the text and know what the next thing is. So DALL-E is combining the two, and you can talk to it and say, give me something. So this example, what I was showing you is real as a demo from DALL-E from their site. If you go to OpenAI, they have a lot of demos, and it says an armchair in the shape of an avocado. And then it gives you that. So they have like weird combination of words, and it creates that as an image, and it gives you a bunch of them. It's all originally created images. It's not an image from the internet. So that's their claim to fame. So now I have a question for you. In the autonomous vehicle world, the car is driving, sees the road, and it's been trained with all the images. Now, where will you use DALL-E? Is there a use case you can think of to use DALL-E in dealing with autonomous vehicles? And I want you to drop off if you have to. I want you to write to me if you have a suggestion on what this is, because I will answer this question in the class tomorrow. There's a beautiful use case I can think of. Cyclist with a large bag is an image, and you can train it with a better image. Dan has a beautiful idea. Generate images for a blind driver. That's beautiful. I had not thought of that, Dan, but that's a very, very beautiful use case. I was thinking of something else for safety. So the idea is you talk and you take the words, and the car today is trained by images, but the car is going to be able to interact and respond. And so think of that and talk to me in class tomorrow. And if you're interested in signing up for the class, tomorrow's class is free and open, not free, it's $250, but it's open for everybody. I do not want you to drop off and not take the class. If financial affordability is the issue, then you talk to me. If you're serious about learning this class, I want you in the class because it's 2 hours, and then you'll have a quiz, hopefully, that's it. But the second piece is the exciting piece, which I'm going to give to 10 of my students. And you can take this class and come up for the others also. It's not like I'm not pre-selecting anybody based on what they've already done. So what we are going to do with the second part of the class, which is the live lab part, which is the 6-week version of the class, is we are going to work with an autonomous vehicle delivery bot, get a business problem. And there is a method of taking a business problem to make it into a problem statement. What does that mean? So if I say, I want to increase revenues, or in this case, it says, I want to improve the ETA of my delivery. It's an English sentence. Even if you put DALL-E on it or you put GPT on it, it will only understand what it means. In the brains of the algorithm, it cannot build a model to increase revenues or to increase its speed or to increase its delivery, increase its safety. It cannot do that. So it needs to be translated into a language as rows and columns. So the common method of doing problem statement is you take what you want the AI to predict, and then you see what are your input and look at the data, and then you define the problem statement. So I have come up with a 4P approach. This is my approach. And this is what I teach in class. And I will have the students form a team, and I will actually put a team together. So you have multidisciplinary people together, and you say, what is the business problem? And then we go through this. What are the pain points? Ananya has been through that. Emmanuel has been through that. They've come and demoed earlier. And then we go through the 4 Ps, and then we come up with how many arrive at multiple use cases. And then since we could do this theoretically and say, yay, we've built a model. Now we form, this is the use case, and then we can go build the AI model for it. But that's not what we're going to do. We are going to take the business problem from the business partner, from the autonomous vehicle delivery business. You're going to learn from me this 4P approach. And then we're going to come up with multiple use cases. We're going to go back to the business partner and say, hey, these are the use cases we picked. This is what we recommend to solve this problem. Do you have the data for it? Show us the data. We're going to have a conversation with them. And they might tell you something new. This is what happens in real life, and you have multiple stakeholders. They might have a different way of solving it, or they might have a limitation on data. There might be something in their business acumen or a bias, how they want to do it one way or the other. You'll get a taste of that reality. And in this case, we will go back. So we will have 3 touch points with the business. First, to understand the business case. Second, we'll go back and get the actual use case and come up with a recommendation. And then we'll go back and say, okay, if we need anything from the data, we'll go back and forth. I'll get that for you. And then we will go back and say, here's a recommendation. And then optionally, I'm going to have some of the students go write a case study. We'll have at least 3 of them work together to write a case study. I've done that with Mercedes-Benz in the past. And then you can publish the case study and go put it on your name, and it can go on Amazon and anywhere, right? So that's the plan. So if you just want the data science, get the foundation, fundamental models, the classification, regression, and all that stuff. I'll teach you an English version so you feel really comfortable. I'll give you enough tools in a non-code AI setting so you can go play with it. And then you can really, really get, solid foundation of data science, and you get a data science certificate. That's tomorrow's class. If you want the longer version of the class, talk to me. I want to see whether you can work on this. If you have done other things that I think you need to work on this, it's fine. You can be a product manager, you can be a business manager, you can be anybody. It doesn't matter. I'm just being picky on making sure I have people who can work with each other and not more than 4 or 5 people in a team. And then because we need to work with the business client, right? The delivery bot company. So that's my plan. And then that team will finish 3 touch points with the customer, lesson from me, 4 hours live. And then they will come and hopefully demo and have a case study to show. The timing wise, you will have 6 hours of live hours for the longer version of the class, or the 2 hours tomorrow with the shorter version of class. And then you'll get office hour with me, independent of whichever one you go. I'll even assign a mentor data scientist to work with you if that's needed. And we'll have a TA for the class. We have Kritika, who's going to be a TA for the class, so we can help you. So you'll not feel intimidated, you'll be learning. Okay, with that, I want to wrap up. Thank you, everybody. Here is the link if you want to look at the class, or if you want to sign up. I want to see whether I can show that link also. It's here, I think. Okay. And what I'm going to do, this is MailChimp/Business School of AI/NoCode AI. This is the link. What I'm going to do is I am going to embed today's recording right here. So if you want to come back, watch the recording, it's going to live here. Okay. And then you can tell your friends also if you want to learn data science or come back, work with us. And that's it. Any last question anybody has? And give me feedback if you find this useful. If you want to be part of the class, talk to me. I want this to be part of your learning journey and the right time. So I'll help you if this is the right thing. I'll tell you if this is not the right thing. Some of you know I do that I deter you away from some classes. So with that, I'm going to wrap up. Thank you, everybody. Stay safe, and I will be in touch. And I will see you at Weekly Wednesday on Wednesday, or I'll see you at the Sudha live stream on Friday. Doing 3 of these days, but the pre-class is only when I have a class coming up. Otherwise, there won't be a pre-class. So with that, I'm going to wrap up. Is there any last question, comments, guys, or this is good? Awesome session. Thank you, Suresh. So yours already signed up. So I see Suresh and Ananya signed up for the class. So I'm going to see you both. Anybody else who wants to join, you're welcome. I think they've joined for the longer version of the class, but you're welcome to join just the data science also. But talk to me 100%. I'll tell you if the class is right or wrong for you. And I do not want finances to be a limitation if you're thinking about that, because the full class costs $499 and the data science class is $250. But I need you there. I want you to learn. I want you all to go and change the world and be part of this. And I want more non-coding AI product managers and business people to be in all the conversations, to be in building AI beautifully and make it ethical. Thank you so much. Bye, everybody. Okay, thanks, Baptist. I'm glad you loved this session. Thank you. Thank you for your kind words, guys. Okay, bye, everybody. I'm going to stop the recording. Okay, stop the live stream. Stop the recording.